As we continue with Chapter 7, Section 1, the examples get a little more difficult, so I'm not putting that many up at a time. Now, as we look at example 12, we need to factor that. And what you first need to know is that this is the sum of perfect cubes. And you have to know how to factor that. We did that in an earlier lesson. And the answer is you put parentheses for 2 terms, parentheses for 3 terms. We're going to factor the sum of perfect cubes. The rule is we take this sign and put it there. Then for the middle term, we have opposite signs. And now we take the cube root of each of these. So the cube root of x to the third is x. The cube root of 1 is 1. And then now we square this first term. Multiply these terms together, disregarding the sign, because we already have our sign. This is an x. Square this term, and this becomes a 1. Now again, it's over what we have here. And you may note that this, and you can always take a 1 out, this is the same as this. So this will cancel out. And our answer then will be x plus 1. But for this one, you had to know that that was a perfect cube. And you had to know the recipe for factoring a perfect, the sum of perfect cubes. If this were negative, then this sign over here would be negative, that one would be positive. But the recipe is a parenthesis for 2 terms, parenthesis for 3 terms. Whatever sign is there goes there, opposite sign there, and then cube root, square that, multiply, disregarding the sign, and then square that last term. So this is sort of a special case that you're going to have to work with to master it. All right, for number 14, again, you're going to have to factor it. So let's factor the top. There's no common factor to take out. 8 times 9 is 72, and we need a negative 1 in the middle, so our 9 will be a negative and our 8 will be a positive. Again, we check by foiling. And this is a perfect square trinomial that you may recognize will factor into its binomial square. And here we see the common factor. So this over this will be our final answer. And remember, you cannot factor out the x's because these are terms. You can only factor out common factors. Okay, again, they're getting more challenging. And as we look at the top, and again, we want to factor and then cancel out common factors. As we look at the top, we see we could take a 2 out of there. So we get a 2 out, and then this becomes x squared minus 36. And we'll factor the bottom. We could take a 6 out of there. X minus 6. But we may note that this can still be factored. This is now the difference of perfect squares, and the difference of perfect squares factors into their conjugates. So this is going to become x plus 6, x minus 6. So we started with this. We took out the common 2. Saw we had the difference of perfect squares. We now factor that into its conjugates. And we factored the bottom already. Now we see a conjugate that is common factor. And our answer will be 2 times x plus 6 all over, well, maybe I can do some more canceling here as I look at this, over 6. Yep, now the 2 and the 6 I can cancel out. This will become a 1, and this will become a 3. So our super final answer is x plus 6 over 3. And again, you cannot cancel this 3 with the 6 because these are terms, not factors. You can only cancel out common factors. In this next one, they want you to factor the 4 terms in the numerator by grouping. Again, we did that earlier as well. Here we're going to take a 4 out, and we get x minus 7. Here we're going to take a y out, and we get x minus 7, which will become 4 plus y over x minus 7. Again, using that technique we had earlier. And this is all over x minus 7. So these cancel out, and our answer is just 4 plus y. Now if you had y plus 4, that's good too.